Hello everyone, welcome back. Now let us look at the stages of Box-Jenkins modeling procedure. The Box-Jenkins approach uses an iterative model building strategy that consists of selecting an essential model, estimating the model coefficients, and analyzing the residuals. If necessary, the initial model is modified and the process is repeated until the residuals indicate no further modification is necessary. At this point, the fitter model can be used for forecasting. The basis of Box-Jenkins approach to modeling time series consists of three phases. The Box-Jenkins modeling procedure involves an iterative, mainly three-stage process. The first one is data preparation. This is the first step we do before anything else. It involves making sure that the data is ready for modeling by checking for missing values, outliers, and any transformation needed. But the first step of the stage of Box-Jenkins model, the first one is model selection. The second one is parameter estimation. And the third one is model checking. This step provides a structured framework for analyzing and forecasting of the time series data. Next, we move to the model selection or identification phase and the Box-Jenkins approach. The Box-Jenkins approach usually requires at least 50 equally spaced observations in a time series to work effectively. Before modeling, the data should be checked and cleaned for missing values, extreme values, or any distortions that could affect the result. Sometimes transformations such as logarithms or inverse functions are applied to stabilize the variance. The series used in an ARIMA model must be stationary, meaning it has a constant mean and variance over time. If the series is not stationary, it is differenced until the stationary is achieved. For series with seasonal patterns, seasonal differencing may also be applied to remove systematic seasonal effects. This phase ensures that the data is ready and suitable for building a reliable ARIMA model. After achieving stationarity, the next step is selecting the model parameters. We need to determine P number of autoregressive or the order of autoregressive, Q number of moving average or the order of moving average, and D is the number of differencing to be stationary if it is your data is not stationary. The goal is to select a parsimonious model, meaning a model with a fewest parameters while still fitting the data well. Tools used for model identification, plots help determine the appropriate values of the order P and Q by comparing the sample autocorrelation function and partial autocorrelation function patterns with their theoretical behavior. In addition, prefer the model with the lowest AIC or BIC, keeping in mind that BIC favors simpler models more strongly. Always check residuals afterward. Good AIC or BIC does not guarantee the residuals are random. Once a tentative ARIMA model PDQ model is identified, the next step is parameter estimation. This involves finding the values of the constant term and the model coefficients such as the autoregressive and moving average parameters. The goal is to determine the numerical value of the coefficients that best fit the observed time series data. Several methods can be used to estimate these parameters. Most produce similar results, though some may be more efficient depending on the model. Parameter estimation usually relies on a function minimizing of the algorithm, such as quasi-Newton method or other nonlinear estimation techniques. Accurate parameter estimation is crucial because it is ensures that the model represents the series well and can produce reliable forecasts. The next step after identifying a tentative ARIMA model, parameter estimation. The parameter estimation to maximize the likelihood of observing the given time series data. This is often done by minimizing the sum of square residual. Remember, residuals are the differences between the observed value and the model's predicted value. The best parameter estimates are those that make the model prediction as close as possible to the actual model. In practice, this means we need to find the numerical values for each coefficient so that the model fits the series as accurately as possible. Accurate parameter estimation is essential for reliable forecasting and model performance. Once we have estimated the parameters, the next step is model checking or diagnostic checking to ensure that the fitted ARIMA model is adequate. The key steps include: the first one is residual analysis. The residuals, which are difference between observed and predicted values, should behave like random noise or white noise. No patterns should be remain. The second part, autocorrelation function or partial autocorrelation function checking, we examine the autocorrelation and the partial autocorrelation functions of the residuals. No significant autocorrelations should remain. Statistical tests such as the junk box test are used to confirm that residuals are independent and the model is capturing the structure in the data. Model refinement and repeat. If the residuals are not random or the forecasts are poor, we adjust the model parameters and repeat the process until the residuals behave like white noise. This step is crucial because it validates the model before using for forecasting future values. That wraps up our discussion on the stages of the Box-Jenkins model, including data preparation, model selection, parameter estimation, model checking, and forecasting. Now that we have covered these fundamentals, we are ready to move on to the next chapter, where we will explore the next chapter. Thank you so much.